Hello and welcome to Basin Safety Monthly Safety Trainings. This is your safety instructor, Jonathan Greiner. This month we're going to be covering slips, trips, and falls, walking working surfaces, and fall protection. Thank you guys so much for tuning in. This is one of the highest incidents of fatalities and injuries in the general industry, so definitely worth our while. Thank you very much, and let's get this safety started. All right, so covering our agenda here, we have quite a few different elements of this training. So breaking it down by content, we have definitions we're going to be going through, slip, trip, fall statistics, and that's what STF stands for, risks of slips, trips, and falls, regulatory information, general causes of slip, trips, and falls, factors that increase the likelihood of slips, trips, and falls, and prevention, probably the most important part. All right, so with falls, there's a couple different categories that we look at. One is the same level, and the second one is from elevation or different level. So obviously when it happens on the same level, it's considered a same level fall. So slipping over debris, tripping over debris, slippery surfaces, changes in elevation such as like a curb stop or, a crack in the sidewalk would be an example, or a hose, a cord, etc. that we would trip over. Those are kind of the causes typically of same level falls. From an elevation, same stuff, except for there's another level you can fall down to. So stairs would be an example of that, platforms, ladders, loading docks, things like that. Even, a rig on our floor, if that's, maybe only 5 feet up or 4 feet up, falling off of that onto the ground would be an elevation fall. So getting into some basics definitions here, this is not rocket science, slip, trips, and falls. So slip is essentially when we have too little friction between our foot and the working area, the walking working area, and when that friction isn't enough, we have a slip. A trip is where essentially our center of gravity is overcome by typically it can be a slip, it can be tripping over something, contacts an object in the way, or there's a drop to a lower level unexpectedly, making our balance off. And a fall is obviously when the center of balance is completely overcome and we strike the lower level or the same level with any part of our body except for our foot. So some statistics here on slips, trips, and falls. It is the most common occupational accident, period. In 2021, which is the most recent statistics I have, there were 2,864 workplace falls, about 100 per day, and out of those 100, one of them resulted in death. So from, again, the same time period, 30% of all workplace accidents were considered falls. And in 2021, 22% of all workplace fatalities were fall related. So 1 out of 5, a little bit more than 1 out of 5 actually, fatalities are fall related. So obviously, for any incident, there's going to be costs. But if we look at 1 out of 5 fatalities and almost 30% of workplace injuries nationwide, if you look at injuries as a cost center. So what does it cost if someone gets hurt? Not just that individual's hospital bills, but obviously they can't work, so that's lost wages, investigation time, the whole nine, right? What are the costs? There's a lot. Temporary, permanent disability, I've seen this. Reduced quality of life, obviously, if you can't do the things that you want to do. And then there's the inconvenience factor. And then some of this, even a psychological factor, can lead to depression, anxiety, etc. just from, hey, I can't work and do the things I want to do. So that reduces the quality of life, therefore has some unintended and long-term consequences. So regulatory information, this is an OSHA 1910 category for, general industry, part 22. It essentially says, hey, this is what we need to do to make sure that slip, trips, and falls don't happen. So we got to keep areas clean and sanitary. We want to keep floors clean and dry. If there's wet processes, we want to make sure the designated areas such as aisles and passageways are kept clear and in good repair, and that permanent aisles and passageways are marked. Depending on where you're at, this may happen or it may just be obvious. And really the intent here is that it's obvious where people are supposed to travel. So getting a little bit deeper, 1910.141 goes a little bit more in depth with, again, keeping things dry. And then this is more in the sanitation side. And then also making sure that during the wet processes that anywhere where people are going to stand, that there's a mat or a platform provided. And then with regards to, especially in construction, this is where we see it. Although it is in general industry too, if there's holes in the floor, the big one that I always think of is shop bays like Jiffy Lube and places like that, where you get your oil change. They'll have those underground areas where the oil techs can go. A lot of people fall in those every year, like a lot. Like the number is staggering. And you're thinking, hey, man, like, why don't you get, and now they do have technology, technology might not be the right word, but they have systems in place that can prevent people from falling into those, but they're not everywhere. In fact, I bet if you go to your local Jiffy Lube, that does not exist. So once a car pulls out, obviously it's a big opening in the floor, someone sweeping with their back to that, or just walking by, not paying attention, looking at their phone. A lot of times people fall in, and just, concrete is not very forgiving. So, stairway floor openings, ladder floor openings, any floor hole at all that could be walked into. And really the standard there is over 12 inches. It needs to be guarded or covered. So causes of slips, typically wet or icy conditions are going to be, greasy grease as well, will be our main culprits for that. Also dry contamination on floors. Again, that will prevent friction from occurring between the foot and the floor would be, reasons for slips. Highly polished floors, obviously. My wife today was talking about tiling outside, with just typical tile for inside. And I was like, yeah, that's not a great idea, baby. Like, it would look nice, but it's definitely going to be dangerous out here in North Dakota. In some places you can get away with that where you don't have ice, obviously. And just from let's look at just safety, right? Not just, hey, what about the grout? Forget all that. Let's just look at the safety aspect. Obviously, ice and tile are a terrible mix. Freshly waxed floors, transitioning from one level to another, all these do cause slips. Also, sloped walking surfaces, loose, unanchored mats or rugs, or non-rubber bottom mats or rugs. My wife loves these rugs. I don't know why I'm talking about my wife so much today, but she loves these rugs. You get it, the Wayfair or Home Depot or whatever. She loves them. So we have them everywhere. And some of them don't have the rubber bottom. And those, when you're coming in from outside, you're taking your shoes off and you almost slip across the living room. Those can be an issue. We all see those. Loose tiles or floorboards that can shift. And then obviously wet, muddy, or greasy shoes would also cause potentially slips. Ramps without skids or slip-resistant surfaces as well. Metal surfaces such as platforms, construction plates, or covers on sidewalks and roads, again, that don't have grading, can definitely cause slips. Getting in and out of heavy equipment or vehicles potentially, especially semi-trucks, etc., if we're not using 3 points of contact, also cause slips. Climbing up and down ladders can be slippery. The surface there for our foot is typically not a whole lot. And then if you add water, mud, or grease to any of those surfaces, then, we definitely have an issue. And you can see here on the crane, obviously he's getting up into the cab of the crane, but then there's a way to get up onto the upper platform. And, it's just not very wide. So there's also environmental factors, as I mentioned, rain, but then frost and snow, ice as well. And even human surfaces can cause this. Uneven surfaces or terrain, rocks, irregular surfaces, gravel, scoria, all of these different elements can definitely cause slips or trips potentially. Same kind of stuff for trips. You add any of those slip factors with obstacles in the way, pieces of wood, cords, cables, boards, etc. All these sorts of things can potentially cause trips. Open cabinets or desk drawers, yes, possibly. In my tool shop, I have these great work tables. They're Works tables, actually, is what the brand. And they have these kind of clamps. And the clamps have a long center bar on them. And if those are extended all the way, I'm always hitting these things. It's not causing me to trip, but it's definitely causing me to turn. And obviously, if there's stuff on the ground, that could... and you're going to say, well, why don't you spin it? And now that I think about it, that's actually probably what I should be doing with those. But really anything, I've seen a lot of people, and I'll admit it, myself included, hit the ball hitch on the back of the pickup. So now I have a ball hitch that flips the ball inward when I'm not using it. and that has been quite a saving grace. But yes, even things like that. And I hate to admit it, but I mean, stitches. I mean, I didn't get stitches, but I've seen stitches from that. So yeah, it can definitely cause injury. Changes in elevation, unmarked steps, carpets or mats that are, again, not laying flat or have rolled up edges, non-rubber bottom again, missing even floor tiles, irregular walking surfaces, and again, slopes, things like that. Damaged steps, non-uniform or irregular steps. Here's an example of some workover rig stairs from an aluminum build that, just get damaged over time. A lot of reasons for trips. This isn't even the last slide. Accumulated waste, materials and debris, cables, pallets, tools, objects protruding from walking surfaces, uneven surfaces, sidewalks, curb stops. So this is the last slide. So there are also numerous common trip hazards on work sites and locations, scoria being the main one that we see, tank farm liners, ice and ruts, all of these sorts of things exist on locations and cause slips and trips. So some other things increasing the likelihood of slips, trips, and falls: poor lighting, glare from the sun, using bulky equipment or awkward PPE, loud noise or distraction, temperature, humidity, or precipitation, and then traffic type or volume. All these things, again, distractions will, someone's looking a certain way, etc. This can cause slips, trips, and falls. So also carrying objects and equipment, this is one I like to focus on because I've seen it so much, is when people are carrying specifically heavy or awkward loads and ones that prevent you from being able to see your path clearly. That's where I see a lot of slips and trips. Even if it's something small, then you're not prepared for it and you don't know the situation because you can't see it. It can cause you to misstep into something that's not going to help your friction at all or your traction. Pushing and pulling objects, same thing. And then again, multiple times I've mentioned this, changes in elevation. So personal things as well: age, body shape, size and mass, gait dynamics. Yes, the way that you walk, physical condition, illness, psychological factors, stress and distractions mostly, medications, alcohol or drug effects. And if you've ever had a couple too many, you've definitely seen the potential of that. And then also visual perception and eyesight. Factors increasing the risk of these behaviors as well: poor housekeeping, just guys and crews that keep stuff everywhere. We've all worked with them. It's annoying. I like to keep my work area as clean as possible. Not all the time, but definitely like every break or whatever, I'll make an effort to make sure everything's kind of at least piled together. It doesn't need to be exactly where it's going to be forever, but at least piled together to be out of my way when I'm working. Making sure we clean stuff up more often. Having a good hygiene practice is good. And then, failing to use signs and kind of alerting people when slip, trip, and fall hazards are present also increases the likelihood. They are preventable. This photo, I think I only have this photo here, and I love to show this photo. I took this photo with my BlackBerry. Shows you how long ago I took this, and I wasn't even a quick draw with that camera on that phone, but this guy was doing this work over here in Tioga while I was doing an OSHA class, actually. Specifically, I don't know if I was on the topic of ladders, but let's pretend I was. So I'm doing a class on ladders, and behind me is a large picture window. I think it was like an 8x10 window, just massive window. So the whole class is looking out the window at this guy, and they're pointing, and I turn around. I'm like, holy smokes, I got to get a picture of this. And believe it or not, this guy I ended up meeting years later today. He messaged me on Facebook, this guy. His name's Noah. He's from Tennessee. Noah, he is not the safest guy in the world. Random that I met him years later. He actually came to our shop to build a wall. We needed a wall built, and he's a contractor, and it took me a few days to figure it out. But the thing about Noah is he has one eye that doesn't really work very well. He had some sort of thing as a kid. Anyway, long story short, he wears an eye patch. So this day I went over to him. I kind of just stopped work. I'm like, hey man, you might want to get a man lift. This is a bad, I could see a lot of things going wrong here. And he had the eye patch on. And then again, he got hired to build this wall at Basin. Safety, and 3-4 days into the job, I walk out the shop and there's the eye patch. And I'm like, it was you. And I showed him the picture. We had a good laugh. And I'm like, you will use fall protection on this job. Because habits are habits and they keep happening. So, we had to kind of help Noah with his habits. Making sure that we're using ladders and stairs with caution is important. Practice safe walking procedures, etc. All these things are important when practicing good, good housekeeping and working practices while working at heights. Design is also important, making sure we have enough area for people to walk, especially where vehicles are moving and equipment is stored. That's pretty important. Including anti-skid plates, matting, rubber bottom rugs was an example that I used, but a lot of different things, anti-slip coating, all these things can help significantly in preventing slip, trips, and falls. And again, this is all prevention, right? So we talked about why people fall. We know that. Now we're really focusing on preventing people from falling. Again, mats, if there's wet areas, drainage, sloping things slightly so that water and material kind of has a place to go rather than pooling in the work areas. Things like that are extremely important. So we want to make sure that we keep our eyes on the path and can see the path at all times when we're working. We want to walk kind of a good, steady pace, like we're strolling through the hood, We don't want to run or scurry wherever we're going, and I love the word scurry. I don't know why I like it. I just like it. Don't read or write or work while walking. Typically, this is going to be texting nowadays more than anything. 3 points of contact when ascending or descending any elevated surface, and make sure we can see, right? We want to make sure we have light on our work path as well. Some other safe work procedures. Before you lift anything, check to make sure your path is clear, your views are not obstructed. If we can, use carts or wagons or something to move loads. And then if we do have to carry loads, we want to make sure we do that close to our body and get our body close to whatever surface we're lifting it up to so we don't strain the back. Specific winter topic here, winter focus. We want to make sure we have the right traction control devices on our boots. Absolutely. I've fallen multiple times without having these on, and trust me, it's better to have them on. So I've got I'll show me in the next slide here. I have the midsole cleats. I love them. We want to make sure we're staying slow, walking like a penguin, and then make sure our boots are clear of mud and rocks and things like that. So we ensure that we have the most traction possible. So here's some winter footwear options. We have chains, PVC grips, and midsole cleats. I like the chain ones. I do have a set of these. They just don't last. They start to rust. The rubber around it, they're just kind of cheap. PVC grips, same kind of deal. For whatever reason, I always bust these things putting them on. I think my boots, I'm a size 14, so finding a pair that fits me is hard, and then I just tear them up. And also, I think that they're kind of a safety hazard. The midsole cleats are great because they don't actually, as far as the ball of your foot and the heel of your foot, they're not messing with that. They just give you added traction right there in the center where you need it. And it's good to kind of obviously walk a slightly different when you have these on, but you can also flip them up when you don't need them if you're walking on metal or some surface that they will slip on easier. I'm just a big fan of the midsole cleats, but get what you will. All right. So our next topic here, and we can see here, ice is slippery, and we want to wear fall protection if we're at heights without guardrails, etc. So walking working surfaces, we have a couple things we want to cover. Getting into this a little bit, breaking this down, we're going to talk about housekeeping a little bit. I've kind of already went through this a good bit, so some of these I'm going to skim by a little bit quickly, so just know that. Guardrails, we're going to talk about those, and we saw that in that last slide. Loading requirements, floor openings and guards, a little bit more into that, but again, I'm going to skip through that pretty quickly. Scaffolding, ladders, heavy equipment and vehicles, and then we're going to wrap that up and get to our last topic of the day, fall protection. So housekeeping, again, keeping aisles and stairs clear of clutter, keeping stuff out of our walking area, not having things that we can trip over, and make sure every surface or additional surface that we've laid down is secure. So again, housekeeping really quick, mud, debris, water, we want to keep this to a minimum. If there's a spill, clean it up right away. And then during that period of time, make sure to, cordon off that area so that people don't unintentionally walk into it. Aisles and passageways, basically, again, the intent needs to be clear that that's where people are supposed to be walking, or you want to have it, marked off and then keep that area specifically clear. Covers and guardrails where we need them. We want to make sure that open pits, tanks, lower levels, any area where someone can fall. Now, the truth is that in general industry, 4 feet is the necessary requirement to have fall protection, right? So you need 4 feet. So like 3 feet 11 inches, let's say 3 feet 11 inches, and 11/16, right? Just pretty much 4 feet. You don't have to have fall protection, but a fall from that height will definitely cause injury, or at least humiliation. Most likely injury and humiliation. So we want to make sure that we're just kind of thinking this through. It's not just about that 4 foot number, but again, the standard is 4 feet. You need to have fall protection or guardrail or something like that. But we want to do everything we can to keep people from falling. We want to prevent that from happening. So if there is another, a level, a higher level that's been built, we need to make sure it's engineered. We understand the weight capacity and that we don't overcome that. I was looking at a building this year. It's no secret we've been trying to find a new building, either build or buy, and it's been a tough process. So if my email's at the bottom of this training. If you know a great place or somebody who's looking to sell a building, let me know. But anyway, I'm looking at a building and they had built this, office and a shop. Great idea. Those are nice. But then they said, hey, you know what? Let's store some stuff on top of this thing. And we got up there and it was sagging and you're like, oh man, like we got to get off this thing. The handrails were these cheap 2x4s, just maybe nailed in. It's just a mess. So making sure that areas we're working are designed for people and not going to break or fall through. Floor openings, not super common in what we do, but it does happen. Any area more than 12 inches needs to be protected and covered at all times, or again, have a barrier around it. So what does that barrier need to look like? This is your typical, top rail, mid rail, toe board. So top rail 42 inches, mid rail 21 inches, and toe board 4 inches high. So we want to make sure that stuff isn't getting kicked down off onto people below, and obviously that we don't fall through and stuff doesn't fall through. So that's the idea here, but behind the science here. Floor hole, just like an opening. There is a 4-day OSHA class, so literally 32 hours of training on floor holes. If you're interested in that, I can set you up. Again, email at the bottom of the presentation. The quiz here, probably not going to be something I get a lot of emails about, but there is a class. I think it's in Philly or something. Anyway. So we want to make sure anything over 12 inches, again, is covered. Again, 4 feet is the number, but, again, keep in mind we want to keep people from falling. So yes, painting the side here yellow lets us know that there's a fall hazard, but really putting up a guardrail, a toe board is the right thing to do. Specifically, and or if there's moving machinery or parts that we'll fall into, we want to make sure that we're protecting those as well. Scaffolding requirements, they need to be designed by an engineer. They need to be constructed by a competent person and inspected by a competent person. So anything over 10 feet, typically because these are used in construction, you need to have the handrails, mid-rails, things of that nature. Stairways, essentially anything with 4 or more rises must have a standard stair rail or handrails. And again, that's going to be 3 steps because the top flat platform would be considered the top of the 4th rise. So 3 steps, 4 rises. Fixed industrial stairs, we do want slip resistance. Again, I use the picture of the damaged ones here, but we want slip resistant, which you can see that these have. They need to be able to carry 5 times the expected load, a minimum of 1,000 pounds, meaning you can't just make these, and cheaply tack weld them on. They need to be designed for that purpose. And the width needs to be at least 22 inches, so almost 2 feet. Ladder safety, get into this a little bit. We're going to be talking about this more in the next presentation. So just making sure that the right ladder is being used. It's designed for its purpose, and we're not using metal ladders near power lines. They'll just kind of keep it simple here. 3 points of contact. There needs to be a 4-to-1 ratio when a ladder's set up. I don't know what the ratio is here. I just feel like there's a better way to do this than this photo here, but hey, that's their prerogative, so that's what they're doing. But yeah, 4-to-1 ratio, and then the top of the ladder needs to extend at least 3 feet past the point of intersection. And this ladder is not designed to be used this way at all. And the thing is you could just flip it, just turn the ladder, you know. Anyway, ladder don'ts. The one-legged dandelion, which is what I like to call the one on the far left, that's a no-no. Also, using power lines as your point of intersection is a no-no. We don't want to lean or use multiple ladders unless we have the platform designed for that, which, believe it or not, there is. And we don't want to modify ladder or put them on another surface, such as the far right photo here. These are all no-nos. Fixed ladders really quickly. The regulation was supposed to change last year. We're still waiting for it, so maybe it'll be this year. Cages or wells are required if it's longer than 20 feet, and then a maximum unbroken length of 30 feet. That's kind of where we're at. Mounting and dismounting equipment safely. This is our last couple slides are going to wrap up this portion, then we're going to get into fall protection. Want to make sure we're maintaining 3 points of contact with our feet and our hands. And then also, there's no slippery surfaces. We get those cleared off. There's nothing stuck to our boots. Again, this is not the time you want to be wearing cleats when you're going up industrial stairs, because those will, connect with the metal and trip you. Always want to make sure we're facing the equipment and have a firm grip when we're ascending or descending. So keep 3 points of contact. Again, really pushing this home. A lot of people fall. That's 1 hand, 2 feet, or 2 feet, 1 hand. And obviously, getting off of this equipment, we want to face the equipment and not jump. So getting into fall protection now, we've covered a lot of elements of this, so I'm going to, try not to repeat myself multiple times, but here we go. Let's get into fall protection. Housekeeping. Workplaces must be kept clean, orderly, and sanitary. This prevents people from slipping. Floors should be maintained as clear and dry as possible. We don't want to have congested stuff, slippery surfaces, etc. And this can happen in the course of a job pretty quickly, right? We were dealing with a spud rig this week. When they're pulling casing or tripping out because something's stuck or plugged or whatever, there's going to be fluid everywhere on that floor. There's no way to prevent it. So in that case, they can't have it be clean and dry all the time. So they have to figure out other methods to prevent people from slipping and falling. So any deck or, platform above 4 feet, needs to have some sort of handrail. Needs to be able to withstand the outward push of 200 pounds is kind of the number. So a fall prevention system, like for example, this gentleman here, if he had a, something that he could anchor to with even just a short, tie-off belt or whatever, he would be fine. You can have a 2-foot lanyard or a 3-foot lanyard that prevents you from falling over the edge, rather than having something 18 or 20 feet up that you're connected to. So inspection, obviously prior every day before using it, it needs to be inspected. If it's not working, take it out of service. You can cut it up. You can do whatever you need to do with it, but ultimately needs to be inspected. And we're going to go into that a little bit more thorough here. So a body harness is obviously the part that goes around us. You want it to fit snug. It's going to hit the 5 major, it's typically called a 5-point harness. It's going to be around the 5 strongest parts of our body. So the thighs, pelvis, waist, chest, and shoulders. That's the strong part of our body, because this is going to absorb a lot of force if we actually do fall. And it can be extremely painful. So you definitely want that dispersed across the stronger parts of your body. So you definitely want it to be secure. If you notice the configuration of the lower straps around the thighs, if those aren't secure and something can kind of get in between that and your leg and you fall, it's going to be an extremely bad experience. So you definitely want to make sure it's snug and supposed to pull where it's supposed to pull to protect you. So there's also D-rings, and the placement of the D-rings changes depending on the type of work you're doing, right? Like you're obviously going to have one in the back. Sometimes you're going to want it higher. Sometimes you're going to want it lower, right between the shoulder blades. You have side D-rings, you have one in the front. It just depends on what type of work you're doing. So make sure if you have a harness, it's correct for the type of work you're doing. Really, connectors are any of the metal parts that, hook or loop or a ring. So they have to lock, and they're double acting. So you have to push in two places for them to open. Like I said, there's a lot of connectors on your system, so they should be able to move freely, right? They shouldn't be, tied or twisted or bent or anything. They need into that a little bit more thorough here. So a body harness is obviously the part that goes around us. You want it to fit snug. It's going to hit the five major. It's typically called a 5-point harness. It's going to be around the five strongest parts of our body. So the thighs, pelvis, waist, chest, and shoulders. That's the strong part of our body, because this is going to absorb a lot of force if we actually do fall. And it can be extremely painful. So you definitely want that dispersed across the stronger parts of your body. So you definitely want it to be secure. If you notice the configuration of the lower straps around the thighs, if those aren't secure and something can, kind of get in between that. So determining proper anchorage points as far as height goes, essentially you need to take a few different things into consideration. 1, the height of worker. 2, the 6-foot length of lanyard. 3, the 3.5-foot deceleration distance, and lastly, the safety factor. So you put all these together, add them up, and that's how you get your anchorage point. A lot of times people forget the safety factor, but that's extremely important. So your lanyard is the length of strap that goes from your harness to your anchorage point. Typically it's 4 to 6 feet. It can be flexible, it may not be flexible. It may be fixed, just depends on what type of work you're doing. An SRL can also be used as a lanyard, and typically they're called self-restraining lanyards or lifelines, and they prevent you from dropping if you fall. So they'll essentially catch you. Works a little bit like a seatbelt, where if it pulls hard, then it locks in place so that you don't fall any further. Obviously, the nice thing about that, and really the goal of fall protection, is fall prevention, keeping you from falling over the edge, keeping you from falling down the ladder, holding you tight and preventing that fall from actually happening. So anchor point requirements, just like every part of the fall protection system, need to be able to withstand 5,000 pounds. So each connector on your harness has a 5,000 pound pull rating on it. Now, once you've fallen in the harness, actually fallen, not like been held by the SRL, that harness needs to be removed from service, as well as the lanyard, because essentially they're designed to be pull tested once, or essentially acted on once, not more than once. So we want to make sure it can hold on 5,000 pounds, and that's kind of the main point of the anchor. So handrails, guardrails, not a 5,000 pound tie-off point. As I mentioned before, they are designed for some sort of impact, but it's 200 pounds outward pressure. So basically a 200-pound person can push against it. It's not going to break or bend on them. But as far as falling downward, they're not designed for 5. They may be, like certain barricades or handrails may be designed for that, depending on where you're at. But 9 times out of 10, they're not going to be. So storing harnesses and taking care of them. I recommend hanging them if you got a nice, dry, clean place. You can put them inside of a storage bin, such as the one in the photo here. But you want to make sure that they're mostly out of sunlight. That's the real killer of the material in harnesses, is sunlight. So the less sunlight, the better. But chemicals, oil, ink, you don't want to mark them, because that can degrade the webbing of the harness and lanyard as well. So kind of wrapping up fall protection. Obviously keeping your work area clean so that there's nothing to trip on is big. We're going to talk a little about ladders here in a minute. You want to check harnesses, make sure inspect them, that there's nothing, there's not frays or holes, or sunlight hasn't beaten down and, kind of degraded the quality or integrity of your harness. All the fall arrest components need to be free to move. They can't be rusted, etc. Check your anchor points, make sure they meet that 5,000 pound mark, which, if they're manufactured for this purpose, they will. And then obviously make sure that they're clean and stored properly. So moving into stairways and ladders. So, For the most part, man lifts are always going to be better than using a ladder, but if there's instances where we can't use them, we definitely want to make sure that our ladders meet the requirements of our needs. So the hazards, stairways and ladders may cause injuries and fatalities among workers. This is a photo I actually took myself. This individual was stepping between two ladders in order to hang that piece of fascia there. I think he was about 18, 20 feet up. His name was Noah. I actually met him after this photo and talked to him. He, was taking a risk here and, definitely could have been in a lot worse condition. He did survive this situation, but it was a little bit of a mess. So slips, trips, and falls on stairways and ladders can happen. So by the end of this training, we want to make sure that we understand the requirements for stairways and ladders and the safe practices and requirements as well. So stairway or ladder, there must be a stairway or ladder at point of access where there's an elevation break of 19 inches or more. So that's pretty much our standard. Hey, is there a 19-inch break here? We need to have some sort of step or whatever. So loading docks, etc., need to have. So a handrail is obviously what we put our hand on when we walk up the staircase. The stair rail is actually preventing you from falling over the edge of it, right? So you probably have a handrail heading upstairs, but you probably also have a wall on both sides. Whereas, typically in a lot of open areas, you're going to need that stair rail, such as, at a tank battery. So the strength, as I mentioned, needs to have a 200-pound inward or outward rating. So it needs to be able to prevent somebody from falling through it. Stair rails with 4 or more risers are what require that handrail. So this would be a no-no here. If it has 4 or more, you need a handrail. Have the stairs by themselves. Stairways with 4 or more risers or more than 30 inches high must have a stair rail along each unprotected side or edge. So that's a no-no there. And obviously during construction, you see this a lot. It's pretty normal, but ultimately, if that guy were to just, trip or slip, if it had just rained, he's going to have a very bad day. So dangerous conditions that exist out there, obviously slippery surfaces, etc. So one question I have is, what can we do about stairs, whether over the containment system or the dike, heading up to the tank battery when it's icy? Those are metal stairs. Depending on the type of stairs, and cleats aren't always the best option because they can cause more of a trip hazard. So what can we do? And really this kind of falls into the work practice side of things, walking slowly, taking small steps, not being in a hurry, not carrying heavy things if you can avoid it, etc., because all those things are going to throw off your balance.
If you do find yourself falling, roll with the fall. Don't reach out. Bend your elbows and knees and use your legs and arms to absorb the fall. So you kind of want to do one of those duck and roll situations. Protect the vulnerable parts of your body like the head, neck, and spine, and then don't move if you think you've hurt yourself. Wait for help. And I like to put if applicable in there because, if you're out there by yourself 3 hours from anybody and you've fallen and you're not sure, you're probably not going to get a lot of help anytime soon. But stability of the spine is one of the most important things in the instance of a fall, to make sure that you don't do any nerve damage, because you can, if you've weakened part of that spine and you move it, you can definitely do some serious, potentially disabling nerve damage and continued damage. So keep that in mind. And then also you want to, slap the ground with your hand and extend fingers to absorb impact. So believe it or not, that's a good thing. If you start falling, man, be like, I'm angry at the ground. I'm gonna give her a nice little smack into. That way, you make sure that your fingers aren't going to get hurt. But you want to slap it. You don't want to brace yourself because that is not going to work. So rule of thumb here, if you drop it, pick it up. If you spill it, wipe it up. Keep your eyes on your path or just completely stop moving. If you got to take a text, read your email, stop moving, do your business, and then get on going again. So wrapping this show up, remember slips, trips, and falls are preventable. They are the leading cause of injury every year by far. It's a significant difference. So keep that in mind. Always perform a site walkthrough prior to performing work. that will, especially if that work will travel with you as the day progresses, and remove obstacles, materials, cords, rocks, etc. that may prevent you from completing your task safely and efficiently. And lastly, look before you step, especially out of a vehicle, and always use 3 points of contact. That wraps up our training for the day. So thank you very much for tuning in today to Walking Working Surfaces and Slip Trips Falls, Part A and B. I know you're going to be looking up those statistics on OSHA this weekend. Saturday night, man, you're just going to make yourself, a nice grape juice and peanut butter jelly sandwich and just curl up next to the couch and be like, man, I'm going to dive into these ocean statistics. I know it. You out there have a great, safe day.
And keep that safety going.